Hello and welcome to 5.5, Law of Sines. In this section, we are going to be learning about how to solve oblique triangles. Oblique triangles are triangles that do not have a right angle, or we could say triangles that are not right triangles. And if we have a right triangle, we can solve using SOHCAHTOA. But if we don't have a 90-degree angle, those ratios do not hold and we can't use that. So we need to talk about the notation of these triangles. The first thing is that the angles of our triangle are going to be labeled A, B, and C. So I'm going to draw a triangle here. Oops, that was really bad. Where A, B, and C are the angles and they are uppercase. So let's say this is angle A, this can be angle B, and this can be angle C. The sides opposite their angle, so this is the side opposite angle A, is often labeled with a lowercase a, the side opposite angle B, lowercase b, side opposite angle C, lowercase c. Law of sines is going to help us solve when we have two different options, either two angles and one of the opposite sides, known as angle, angle, side, or two sides and an opposite angle, sometimes known as side, side, angle, or if we reverse that order, right? Oh no, it's the word ass. We're gonna, there's a reason I pointed that out. This, what am I trying to say? Oh my goodness, my brain. Okay, if we have angle side side, this is going to potentially be kind of tricky. So we'll get to that one in a little bit. But these are the two ways we will be able to use law of sines. Now let's get to what law of sines really says. And so we're going to consider the following triangle, which is not necessarily going to be a right triangle, and we'll draw it kind of like we drew the one on the other page. Let's say that's our triangle. We'll label this as A, B, C. That means side A, side B, and side C. And I'm going to add in here, this is the height of our triangle. So let's relate the sides and angles of the triangle trigonometrically and solve for H. Okay, let's consider just this triangle right here, because this little green triangle is a right triangle. And if I look at that, I could say that sine of angle A is equal to the opposite SOHCAHTOA, right? Opposite H over hypotenuse B. Okay, what if we consider this little triangle right here? Well, same thing, we're going to use SOHCAHTOA, and I could say sine of angle B is equal to opposite H over hypotenuse A. Well, now we have two equations that have H, which are the same segment here. So let's solve these for H, meaning get H all by its lonesome. I just solved these both for H, and because H is the same segment here, I can set these two things equal to each other. B times sine of A is equal to A times sine of B, right? Because H is equal to H. I'm linking these pieces right here. And now I can write what is often known as law of sines, where I'm actually going to move this side A to the other side by dividing both sides by A. And I'm going to move B to the other side by dividing both sides by B. And so we see sine of angle A over side A is the same ratio as sine of angle B over side B. And I didn't do this here because we only needed two, but we can extend this to say sine of angle C over C is the same ratio. This is the law of sines. It says that the ratio of sine of one angle over the side opposite it is equal to sine of another angle divided by the side opposite of it. Law of sines is really lovely. This will be our warm-up problem in class. So if you want to pause the video and write it down, you can do so. Otherwise, we are going to talk about that ambiguous case, the case that is a little weird, side-side angle, otherwise known as AS. So if you ever notice an angle and the two sides next to it, maybe be like a little cautious, because this is going to be a possibly weird thing. In this case, there are three possible situations for what can happen. Either no triangle can exist, one triangle can exist, or two different triangles can satisfy those conditions. So let's look at this a little bit more. I'm going to go ahead and draw what we've got here. Let's consider that triangle that we saw before, where let's say this is side A, B, C, that'd be side C, side A, side B. Now, in this case, we are given an angle. So I'm told, let's say angle A. I know that this measure is A. One side, we'll say A, side B, and then another side, A. So angle, side, side. Now the catch is we do not know what this angle C is. So, it could look like this, or it could swing that wide. We don't really know what angle C is. And depending on how long side A is here, we might not actually be able to draw a triangle. So this is a segment, I'm extending this A right here because we know the angle A, but we don't know how long side A is. In order to decide which of these things can happen, we're going to make a table, and it might seem a little overwhelming at first, but trust me, as we think it through, I hope it will make sense to you. So we are going to start by saying in this, we're going to consider a triangle where angle A, side A, and B are known. We are also going to make a note that says angle A is acute here. And we are going to remind ourselves from this last slide, notice how the height of this triangle is equal to B times sine of A, or A times sine of B. I'm going to put those in here as well. Just another reminder, H, the height of this triangle, is equal to B times sine of A, or A times sine of B. We really only care about one of these, I'll point out, because we have angle A and side B, so really this is the one we want, but it's also equal to that. All right, so how are we going to consider? Well, let's look at our first case. Case number one is that side length A is greater than the height of the triangle, and side length A is greater than side B. So I'm going to sketch this for us, right? We know angle A is this, whatever size that is, but we don't necessarily know how long this side on the base is. I know my side B is maybe right here, but B is going to be shorter than A. So let's say A is maybe this big. I'm going to turn that. Maybe I shouldn't have done that. Well, here, let me try again. Okay, I'm drawing A to be shorter than B, but I'm not labeling it. So A is kind of over here. And A, this side length A, is greater than the height of our triangle. So in my triangle here is my height. And notice, if I measure this up against it, I didn't do a very good job, but my A side is longer than my height. In this scenario, how many triangles will exist? Well, as I'm playing around with this, this will have only one possible triangle. That's case number one. One possible triangle here. Our second scenario would be if our side A, is equal to the height. If side A is equal to our height, but A is shorter than side B. So again, we don't know how long this side down here is, but we know angle A is something like this. We have side B, which is some length, and then we have the height of this triangle, which is equal to side A. Well, notice what we have there. We have one triangle. There's one possible solution here, and it is a right triangle. One right triangle. Okay, we have two more cases. Let's consider what happens when side A is less than the height and side A is less than that other side B. So again, we have angle A right here. We have side B, and let's say B can maybe be this long, and our height, I kind of want to do that dashed. This is our height right here. Well, if side A has to be shorter than this side B and shorter than this height, well, A, let's say, could be like this, and what do we notice? Is that going to work? No. This is a situation where no triangle exists. I can't make some triangle out of this scenario. Now, if you've been playing along, you know from above that there were a couple different scenarios. Either one triangle can exist, no triangles can exist, or two triangles can exist. And since we've seen one triangle and no triangle, it's very likely that this next scenario is going to be two possible triangles. Let me lay it out for you. If our side length A is greater than our height, but A is less than side B. All right, let's start the sketch. Again, we have angle A. We don't know how long this side is. We have a side B that is going to be longer than side A. So I'm going to draw side A maybe like that big, but A is greater than the height. So maybe I'll draw my height as that length. So let me square this away, meaning I'm going to make angle A just a little smaller. Hold on. Okay, we're going to go through this again really quick. Side A, this green one, is greater than the height, longer than our height. We can see that here, but side A is smaller than side B. Oops, I didn't do that perfectly. Shorter than side B. Well, what can happen here is because we don't know what this angle up here is, I'll either have a triangle that looks like this, or I'll turn this in a little bit, and it's not perfect, but I'll have this tiny little triangle right here. So this is the scenario where there are two possible solutions. We've got this triangle or this triangle over here. Here's A and here's A. In this case, there are two possible triangles. Now the catch is this table that I have just created is assuming we are given angle A, side A, and side B, though technically it works for any three sides, or excuse me, not any three sides, any one angle and two sides. It works for any three pieces. They don't necessarily have to be A, and B, but I will tell you this right now. On a quiz or a test, I will make it specifically so it is side A, side B, and angle A. So you will be able to use this table here. And we will look at how this kind of plays out in the examples in class. I'm going to go through the examples if you want to pause the video and write them in your notes. Otherwise, we are done with content. We will do these examples in class. Pause the video right here if you would like to write down this problem. Pause the video right here if you would like to write down this problem. And pause the video right here if you would like to write down this problem. Have a great rest of your day.